And welcome to Technical Drawing Solution. Today I'm going to take you through a solid geometry topic. We shall be answering questions extracted from a KNEC paper that is passed. The question involves construction and drawing of a hexagonal-based pyramid. We shall be drawing the front elevation, plan, end elevation, true line, true shape, and surface area development. The question goes like this. Question number 4. Figure 4 shows the elevation of a truncated regular hexagonal pyramid. Redraw full size the given view and complete the A. Plan, B. End elevation in the direction of the arrow E, C. True shape, and D. Surface development. Remember, when we are asked to draw full size, the scale is 1:1. Copy the following diagram, figure 4. The figure shows the plan, a complete front elevation, and the plan is a hexagon of sides 25 millimeters. The orientation of the plan is such that a horizontal line passing through the center would measure the distance across the flat sides. The height of the pyramid is 50 millimeters. A cutting plane of 45 degrees starts 15 millimeters from the base of the pyramid. So the first task is just to copy the diagram as it is. To understand the different orientations of a hexagon, we have two diagrams here that will give us an idea. So the first one here measures the distance across a flat to a flat. So we shall refer to it as distance across flats. And the second one measures the distance from corner to corner, and therefore we shall refer to it as distance across corners. Before we start answering the question, let us first of all look at the complete answer to the question. The answer will look like this. You will notice that a lot of construction lines that have been used to construct the drawing remain in the background. That is, they are not visible. The bold lines have been used to outline only the required answer to the question. That is, front elevation is visible, end elevation can be seen, the plan, true line, true shape, and the surface area development. So anything that you draw which is visible should be the answer to the question, and anything that helps you to construct the answer to the question should remain in construction line. Marks will be awarded for each question as indicated, and we can see here that the way marks have been awarded will also help you to decide what to start with and what to end with, and what to be actually very serious on. So the total marks awarded is 20, and then we can see the distribution of the marks. So we can see here that we have the given view being given 1 mark, the plan 5 marks, left end elevation 4 marks, surface development 4 marks, true shape 3 marks, and then the line work, yeah, and neatness. So that is how we distribute the 20 marks, and you can see that each diagram has been labeled there, and that is how the marks will be awarded. Now let's begin the drawing by drawing one of the vertical sides of the plan, which is a hexagon. We shall start with the plan because we do not know the distance across the flats, and we want to construct the plan in such a way that we shall be able to get the distance across the plan. So draw a vertical line 25 millimeters to represent one side of the hexagon, and it should be in construction line. Locate the center of the vertical line and draw a horizontal line. It should also be in construction line. Draw that as shown. The horizontal line represents a line through the center of the hexagon, touching one flat to the other, and is not measured at this stage. It will also end up being the distance across the flats. Next, we shall draw 30 degrees lines from the top and bottom of the 25 millimeters vertical line as shown. Everything should be light and in construction lines. Get distance across flats. A horizontal line is drawn from the top of the vertical line. This line will intersect with the 30 degrees line, and at the intersection point, drop a vertical line. This marks the end of the distance across flats. So all these other protrusions are not needed. All these other extensions are not needed. Notice that we already have two triangles of two equilateral triangles, this one and this one. Two equilateral triangles pointing towards each other. So the next step is to draw a vertical line passing through the center. We shall then draw 30 degrees lines on top of the horizontal line to give the diagram as shown. Using a 30 degrees set square, in conjunction with the T-square, we are able to draw the 30 degrees on the lower side, which appears as 60 degrees. If there was a horizontal line here, then we would have 30 degrees on the lower side and 30 degrees on the upper side. So the total here is 60 degrees. Divided by 2, there will be a line passing across here. Therefore, if you place your T-square and then set square 30 degrees, you'll be able to draw this 30 degrees to the horizontal. So the hexagon is complete. We can see that this is a vertical, this is another vertical, and on this side we have 30 degrees and 30 degrees. So the hexagon is complete and the orientation is across the flats. Notice that the hexagon needs to be in construction lines. Everything is in construction line until we such a time when we have finished the whole drawing. That's when we can start putting the final lines. So the next thing here is for us to draw the crosshairs. Although not compulsory, but drawing these crosshairs will help you to place your drawings correctly. So in this case, we are going to use 20 millimeters separation from the vertical crosshair. As you can see here, we are also using another 20 millimeters separation from the horizontal crosshairs. Yeah, and then we are also projecting lines so that we are able to draw the front elevation on top here. And the front elevation is also 20 millimeters from the crosshairs. So at 20 millimeters, we can have a horizontal line here representing the bottom of our triangle or the bottom of our pyramid. Using the center line here, we can easily locate the apex of the triangle. We already have the horizontal line from the previous slide, which we got by projecting the flat sides, flat sides, and then measuring 20 millimeters from the crosshairs, and then we got this baseline. After that, then we can project this line, which should be in construction line because we don't need it. We only need it for construction purposes. Then we can measure from the base here 50 millimeters because we know the height of a triangle is 50 millimeters. After placing our pyramid or triangle front elevation in the correct position, that is 20 millimeters from the horizontal crosshairs and 20 millimeters from the vertical crosshairs, then we measure 15 millimeters, the level at which the cutting or truncation will start. So measure 15 millimeters, and at 15 millimeters, then we can measure 45 degrees, which will give us the truncation. Everything should be in construction lines. Number your points. We can start numbering from the plan, and you can number them anyhowly. So in this case, we have started 1 at this point, 2, 3, 4, 5, and 6. So once we have named that, we know that in the cutting, we shall transfer this, because here we have 2 points. In the front elevation, we can see 5 and then 6 behind it. So 5 and 6 behind it. We can also see here 4 and 1 behind it. 4 and 1 behind it. Then we have 3 and 2 behind it. So 3 here and 2 behind it. Yeah. Now the numbering changes as we move up. Up on the cutting, we know we are cutting the same line. We are cutting the same line such that if this is 2, then where 2 is cut above, we have 2 prime. And if this is 3, then where 3 is cut above, then we have 3 prime. And the same thing here, 5, and then at the cutting, 5 prime. And then 6 and 6 cutting will be 6 prime. Yeah. Notice here, we cannot locate the cutting because there's no intersection point here. Yeah. How did we get the cutting here? We got to the cutting point here and then projected directly downwards so that in the intersection points, we could identify that what part was being cut or which line was being cut, and therefore it gives the same numbering. So that is how we do the numbering, and we coordinate the numbering from the front elevation, from the plan to the front elevation and back and forth, and that's how we do it. After completing the front elevation, we now have the plan and the front elevation. The plan is not complete since the cutting points are only 4. We are supposed to have 6 cutting points to give us the shape of the cutting on the plan. So that is yet to be done, but the front elevation is already complete, and the only thing that is remaining is to make it bold as far as the cutting is concerned. Now, next, we shall draw a 45 degrees deflection line to give us the end elevation. And therefore, after we have drawn this line, then we can project each point, like 1 here, and then all the way up at 90 degrees, because we have this 45 degrees deflection line. It will deflect this line at 90 degrees, and therefore this 1 will be transferred there. So this is point 1, and then here we are projecting 2 points, 6 and 2, and then 6 comes before 2, and therefore bring it here, and we shall have 6 on the lower part and 2 on the upper part. Then 5 and 3 will come all the way here. 5 and 3 will be that line. Then we have the last one here as 4. So how do we get the apex of the triangle? We project the center all the way and also project this line and this line, so that we have the total height. And once we have that point up there, then we are able to draw these lines towards the apex, and we end up having our triangle. So once we have drawn the end elevation, this is the end elevation all the way like that. that triangle which represents the end elevation. Then we need to get point 1 and 4. Since we could not get them directly from the front elevation, so we have to get those points from the end elevation. And what we shall do is to get them from the front elevation all the way to the end elevation, such that here we have 1 prime and 4 prime. That point represents 1 prime and 4 prime. So if you bring it across here, you shall have 1 prime there, because this is line 1, yeah, and then 4 prime there because this is line 4. So we have already located point 1 prime and 4 prime. Then we can project them back to the plan to get 4 prime, and we can project 1 back to get 1 prime. It is good practice to also number all your parts or all your points, because we had transferred this, projected this 6, 2. You will see that this is 6 and 2. Then we had also projected 5, 3, and this is 5, 3, and we had also projected 4 here and then 4 there. So we are almost done because on the end elevation, the cutting is already complete. The cutting is already complete because we already have 2, 3, and 2 prime. This is 2 prime, and this will be 3 prime. Then we have 6 prime and 5 prime, and this will be 6 prime, and this will be 5 prime. So on the end elevation, we have already plotted the cutting. On the plan also, we already have 6 points of the cutting. Yeah, this is 1, 2, 3, 4, 5, 6. So the plan is complete. The only thing that is remaining is to plot the lines and make them bold. So remember, everything is still in construction line. Everything is still in construction line, including the crosshairs, including the 45 degrees line, the labeling, and so on and so forth. Everything is in construction line. We are going to finish the diagram first, complete it before we go to making it bold, and actually outlining whatever we need to outline, and leaving in construction line whatever is to be left in construction line. So here you can see that we have completed the cutting here. Here also we have completed, by joining the points, we have completed the cutting. Take note of the bold pencil work. You can see that the upper side of this front elevation remains in construction line, so it is not very visible, but the lower side is completely bold, yeah, and therefore it should be visible. Same thing to the end elevation here. You can see that there are lines which are now not visible, and there are those lines that have been made very, very bold. Yeah, the plan also has the same thing, that we have these lines. You will notice that lines passing across like that, across and cutting the center, have been made light, and therefore they are not visible. Instead, now we are having a hatching here to show that this is a cutting. Having completed the three views, front elevation, end elevation, and plan, the next thing would be for us to draw the true shape. How is the true shape drawn? We draw it from the cutting on the front elevation. So the cutting on the front elevation is at 45 degrees. We project lines 90 degrees to the cutting, 90 degrees to the cutting. So this line represents prime 6 and prime 5. This one represents prime 4 and prime 1. And this line represents prime 2 and prime 3. Once we have extended those lines, at any point we can draw a line representing a line across the plan. So this line over here is an imaginary line that has been borrowed from here, so that the distance between 6 and 5, 6 prime and 5 prime, will appear here as 6 prime and 5 prime. So with your pair of compass and stepping on this point, stretch your pair of compass, you'll measure 17 millimeters and bring it here. From the center line, you can then share 17 from this side and that side. Yeah. Then the next one is 0.1 prime and 4 prime. That is a line passing through this point here. And if you place your pair of compass here, that will be 19 millimeters. Bring it here and share it, share 19 between 1 and 4. Then the next one would be 2 prime and 3 prime, which is 2 prime here and 3 prime, 7 millimeters, and therefore share 7 millimeters between 2 prime and 3 prime. By joining the primes that you have created here, by joining those lines 1 prime, 6 prime, 5 prime, 4 prime, 3 prime, 2 prime, you end up having your true shape. This is the true shape, and the next thing to be done here is to hatch it like you have hatched this one to show that this is a true shape or a cutting. So here you can see that the projection lines have been taken to the background. That means in the first place we were using construction lines, and then once we finished our project, then we went on to use the finish line, and therefore the finish lines became more bold than the construction lines, and therefore we are not seeing the construction lines, yet they are there. They are there, but they are not very visible. And that's the essence of using construction lines up to the end of the project. Next, we shall draw the true length. The true length or the true line, which is this red line over here, indicated TL. So how do we get this line? It is a projection from the plan. and place your pair of compass the center of your hexagon and circumscribe the hexagon. Once you have circumscribed the hexagon, draw a horizontal line to touch the circle, which you have is a resultant of circumscription, and draw a tangent to the front elevation. Extend the base of the front elevation where they intersect. Then you can draw your true line to the apex. Finish the true line with finish line or bold line so that it is visible. Then place your pair of compass at this point over here, stretch it to the length of the true line and draw an arc all the way like that. So after drawing the arc, then you can measure from 1 to 2, or in this case, first of all, label your points here. And how do you label them? These edges are 25 millimeters. So then you will stretch your pair of compass 25 millimeters and cut these portions like that. Once you have cut the portions, then you can start with any point here. We shall start with this point 4, which is here. Then the next one will be 3 there, 25 millimeters from 4. And then we have 2 here, which is also 25 millimeters. Yes. And then 1 there, 25 millimeters, all the way until you get back to 4. You come from 4 and finish at 4. Why is that? Because we are getting this line 1, 2, 3, 4, 5, 6. There are 6 portions, and if there are 6 portions, then you end from where you started. You are splitting this from here, and then you're opening it, and that's how that's what we have actually done there. Next, we are going to measure against the true line. The first thing we have to do is to transfer point 6 prime and 5 prime horizontally to the true line. If you measure that distance, that will be 17 millimeters. You do not need to measure it. You only need to stretch your pair of compass from this point up to that point, and you'll have picked that 17 millimeters distance, and you will place it where you need to place it. Then also do the same for these 2 points here, which is prime 4 and prime 1. Prime 4 and prime 1, transfer them horizontally to the true length or the true line. And if you measure this distance, you'll find that it is 34. And as I've said, you do not need to measure it. You only need to pick it with your pair of compass and place it at its rightful place. The other point is 2 prime, 3 prime, which is at the top here. We transfer it to the true line, and we shall have that point there. If you stretch your pair of compass here, you will measure 40. And as I've said, you actually do not need to measure. You only need to pick it with your pair of compass and take it to where you need it. So we are now ready to start transferring these points. And how are we going to transfer them? We know that 6 prime, 5 prime are at the level of 17. So we look for 6 prime, which will be at 6. Yeah. So here we can stretch a pair of compass 17 millimeters, or just stretch it to that point and then bring it to 6 here and measure and strike that point, and you'll have gotten 6 prime. And at the same time, this point has 2 points, which is 6 prime and 5 prime. You again look for 5 prime and then stretch your pair of compass 17 millimeters, and you will have gotten those 2 points. Now the other points are like this highest point here has 2 prime and 3 prime. So that means that if you stretch your pair of compass from here all the way, you will get 40 millimeters, and that 40 millimeters will be applicable for 3. Yes, measure that, strike 40 millimeters, and you get the point 3 prime. And 2 prime, stretch this one 40 millimeters and measure up to there, and you will get that. So here, as we can see, the first point here is 4. And where is our 4? Our 4 is right here. So that means that our 4 is at the level of 34 millimeters. Yeah, we don't need to measure. Just place your pair of compass at the on the true line, yeah, and stretch your pair of compass up to there. That will have measured 34 millimeters, and strike that point. That will be your 4 prime. Yeah. The next one here is 3. And where is 3? 3 is the topmost. 3 is sharing a point with the 2 prime, and therefore we shall stretch our pair of compass from this point up to the level of 3 up there, and that will give us a distance of 40 millimeters. We don't measure, so we just come here and strike that point over there and indicate that point as 3 prime. Next we have 2, and 2 is also sharing with 3 up there. And therefore stretch your pair of compass to 2 prime, and that will give you 2 prime. 2 prime. Continue measuring depending on the number below here. The number, if it is 1, you go to 1. 1 is at this point. Bring it across to the true length and place your pair of compass here. Stretch that. That gives you 40. That gives you 34, and then you strike that point 34 and call it 1 prime. You do the same to get 6 prime here, the same to get 5 prime, and finally 4 prime up here. So once you have gotten those points, then the next thing will just be to join those points like that, join those points to get the figure that you need. So we have already joined those points. We've joined those points like that using construction line, and once we are comfortable that we have actually gotten the points correctly, and then we shall go on to make them bold or in finish line. So here we are with the finish lines. You can see that we have the bold lines indicating that this is the figure that needs to remain, or the figure that needs to be marked. Yeah. The other lines, as you can see, remain in construction lines. They are thin and light, and mostly should not be visible. They should be at the background. Yeah. But you can see these are bold lines that are very visible, though not thick, because we know that our pencil should be 0.5 millimeters. The tip of our pencil should be 0.5 millimeters, and therefore these lines do not need to be thick. They only need to be very dark, and very, very slim. So here we are almost through. We're only showing part of the drawing, with this one being the front elevation, this one being the surface area development, the end elevation. We have the plan right below this front elevation, and our diagram is almost complete. This is the complete diagram. We are through, and as you can see, we have now used finished lines. The projection lines are not visible even though they are there, and that's how you should finish your diagram. Please subscribe, hit the notification button, and give it a thumbs up. Let's meet in the next video.